Hello out there, welcome to this tutorial on binomial expansion. In this video, we'll be looking at binomial theorem. This is the third lesson on binomial theorem. Check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binomial expansion, including the Pascal's triangle. So we start with the first problem. Problem 1. Expand 1 plus 3x all to the power of 4 and use your result to evaluate 1.06 raised to the power 4 correct to 4 decimal places. So in our expansion, the power here is 4 and the first term in the bracket is 1 and the second term is 3x. So the coefficient of the first term of the expansion will be 4 combination 0. Then the first term in the bracket will carry the highest power. That's going to be times 1 raised to the power 4. At this point, the second term has no place. So we go to the second term of the expansion and the coefficient is 4 combination 1. Then times 1 raised to the power 3. The power has reduced by 1, or we look at it as 4 minus 1, which gives 3. Then the second term in the bracket comes in as power 1 because of the subscript here that is 1. So plus 4 combination 2, then times 1 raised to power 2, then 3x raised to power 2. You remember that? Then plus 4 combination 3 times 1 raised to power 1. This is going to be 3x raised to power 3. And finally 4 combination 4, then 3x raised to power 4. The first term there has no place here. So we have it there. Then we simplify the coefficients. So we have 4 combination 0 gives 1. Multiply by 1, since 1 raised to the power 4 is 1. Then plus 4, because 4 combination 1 is 4, times 1 into 3x, since 3x to the power of 1 is 3x. Then plus 6, since 4 combination 2 is 6. Then times 1, 3x squared will give us 9x squared. Then plus 4, because 4 combination 3 gives 4. Then times 1 into 27x raised to power 3. 3 raised to power 3 is 27, then x raised to power 3. Then plus 1, 81x raised to power 4. 3 raised to power 4 is 81. Then we simplify finally. This is 1, since 1 times 1 is 1. 4 times 3x gives 12x. 6 times 9 gives 54x raised to the power 2. Then 4 times 27 gives 108x raised to the power 3. Then plus 81x raised to the power 4. Then we are done with the expansion. We consider evaluating 1.06 raised to the power 4 using the results from our expansion. 1.06 can be expanded in binomial form as 1 plus 0.06. So we now compare it with this. So which means 0.06 is corresponding to 3x, since 1 is corresponding to 1 here. That means x is 0.02 if you divide both sides by 3. So this is what we are going to substitute into this to evaluate 1.06 raised to the power 4. So we have 1.06 raised to the power 4 will be equal to 1 plus 12 into 0.02 plus 54 into 0.02 squared plus 108 into 0.02 raised to the power 3 plus 81 into 0.02 raised to power 4. This is going to give us 1. 12 times 0.02. 12 times 2 will give us 24. Applying the 2 decimal places, we have 0.24. This is 0.02 squared. 2 squared is 4. Applying the 4 decimal places and multiplying by 54 will give us 0.0216. Then 0.02 raised to power 3. 2 raised to power 3 is 8 times this. Then we apply 6 decimal places. It gives 0.000864. Then finally we have this one as 0.00001296 after evaluating this. So summing them up, we have 1.26247696, and we are to give our answer to 4 decimal places. So we are going to have 1, 2, 3, 4. So we check the 5th digit, which is 7. We round it up by adding 1 to 4. So our final answer is 1.2625. And that's the end of solution to problem 1. We then go to problem 2. We have problem 2a. Expand 1 plus 2x all to the power of 5 plus 1 minus 2x to the power of 5. B. Use your result in A to evaluate 1.2 raised to power 5 plus 0.8 raised to power 5. So we are going to expand this positive part because the difference between this and this is just the sign. Expand the positive part first, then we apply the negative appropriately thereafter. So we start with 1 plus 2x to the power of 5. Since the power is 5, so the first coefficient will be 5 combination 0. This is times 1 raised to power 5. This one takes the highest power. Then this is going to the next term. We are going to have the coefficient to be 5 combination 1. This is times 1 raised to power 4. Then the 2x comes in here to take the power 1 here. So we have 2x raised to power 1 plus 5 combination 2. This is times 1 raised to power 3. And the 2x will take the power 2. Then plus 5 combination 3. Then times 1 raised to power 2. 5 minus 3, 2, or we'll look at it as the powers are reducing. So then the 2x takes power 3. Then plus 5 combination 4 times 1 raised to power 1. Then the 2x takes power 4 plus 5 combination 5. The 1 has gone. We have 2x taking the power of 5. So simplifying the coefficient, 5 combination 0 gives 1, then times 1, since 1 raised to power 5 is 1, plus 5, since 5 combination 1 is 5, then times 1, 1 raised to power 4. So 2x raised to power 1 still gives 2x, plus 5 combination 2 gives 10 times 1. 2x squared will give me 4x squared, plus 5 combination 3 still gives 10 times 1. 2x raised to power 3 gives 8x raised to power 3. So we have 8x raised to power 3 there. Then plus 5 combination 4 gives 5 times 1. Then this will give us 16x raised to power 4. 2 raised to power 4 gives 16. Then x raised to power 4. Then plus 1 into 32x raised to power 5. Since 2 raised to power 5 is 32. Simplifying finally, we have this as 1. 5 times 2x gives 10x. 10 times 4x squared gives 40x squared. This is 80x cubed. This is also 80x raised to power 4. And finally, we have it as 32x raised to power 5. So we are done with this. Then we go ahead to use our result here to expand the equivalent but negative. So what we do here is we consider the power x that is odd and assign it negative. If it is even, it takes positive. So this is going to give us 1. The power here is 1, which is odd. So it goes with minus 10x. This is even. We have it as plus 40x squared. This is odd. It goes with minus 80x3. This is even, plus 80x4. And this is odd, so we have minus 32x raised to power 5. And that's all. We go ahead now to sum them up. So we have 1 plus 2x all to the power of 5 plus 1 minus 2x to the power of 5. So we are adding this and this. So 1 plus 1 gives 2. And plus 10x minus 10x gives 0. So the term with x to power 1 is gone. 40x squared plus 40x squared is 80x squared. And 80x cubed minus 80x cubed gives 0 also. So the term with power 3 is gone. Then 80x4 plus 80x4, we gave 160x4. And this term is also gone, since this is plus 32x5 minus 32x5. So that is gone. We have expanded this now and simplified. So we go to B part of the problem. For B, we have to use the result in A, this is our result here, to evaluate 1.2 to the power of 5 plus 0.8 to the power of 5. So to do that, we expand this. Whatever we have here as value of x is automatically giving us the same value here. So we just need to verify one. So we are going to expand 1.2, which is going to give us 1 plus 0.2. And comparing it with the binomial expression, so we are going to have 2x is equal to 0.2, which means x is equal to 0.1. After dividing both sides by 2, we now substitute x is 0.1 in this result to get the values of this. So we have 1.2 to the power of 5 plus 0.8 to the power of 5 will be this first term, which is a 2 plus 80 into 0.1 squared plus 160 into 0.14. So this will give me 2 and this will give me 0.8 because it's going to be 80 in 2 decimal places. This one is going to be 160 in 4 decimal places, so it's going to be plus 0.016. We ignore the 0 there. So summing this up, I have 2.816. We have successfully solved the problem in problem 2. We then go to problem 3. For problem 3, obtain the first 4 terms in the expansion in ascending powers of x of 3 minus x all to the power of 7, and hence obtain the coefficient of x cubed in the expansion of 4 plus 3x into 3 minus x all to the power of 7. So we start with the expansion first. In this expansion, we are interested in the first 4 terms. and the powers of x must be in ascending order. So we have the power to be 7. So the first coefficient is 7 combination 0. I have 3 raised to power 7 plus the second coefficient is 7 combination 1. Then 3 raised to power 6. The second term in the bracket will appear now as power 1. That's negative x to power 1. We have gotten 2 terms already. So for the third term, the coefficient is 7 combination 2, then 3 raised to power 5, then negative x squared. Then the last term, which is the fourth term, according to the problem, is going to give us the coefficient as 7 combination 3, then 3 raised to power 4, negative x raised to power 3. So simplifying these coefficients, I have 7 combination 0 to be 1. 3 raised to power 7 gives 2187 plus 7. Then 3 raised to power 6 gives 729. Then this is going to give us minus x since the power is odd. Then plus 7 combination 2 is 21. 3 raised to power 5 is 243. Since this is even, so the negative goes away, so we have it as x squared. Then plus the coefficient of the next term, which is 7 combination 3, and that gives 35, plus the coefficient, which is 7 combination 3, which gives 35, then times 81. We're going to have this as negative x raised to power 3. We are done with that. We finally simplify, multiply out the coefficients finally. So the constant term is 2187. This is going to be minus, because this negative times positive here gives minus 5103x. This plus 5103x squared. Then this one again is going to be minus, plus and minus. That's minus. Then multiplying this, we have 2835x raised to power 3. So we're done obtaining the first 4 terms in the expansion in ascending powers of x. So we go ahead to get the coefficient of the expansion of this. So for this, we have 4 plus 3x into 3 minus x all to the power of 7. It is as good as multiplying the result here by this. So we have our result multiplied by 4 plus 3x. We are not going to carry out the complete expansion because it is not all that will give us the coefficient of x raised to power 3. Because if you multiply the constant by the constant, it will give you constant. If you multiply this with power 1 by 4, it will still give you power 1. But if you multiply the constant by this power 3, will still give us power 3. And if you multiply 3x by all this, it's only one that will give you power 3, which is this. So we are going to carry out that appropriately. You can see. So the 5103x squared, we multiply 3x, and 2835 we multiply 4. So this 3x times 5103 squared will give us 15,309x cubed. Then 4 times negative 2835 will give me 11,340x cubed with minus sign. So simplifying this, we have 3,969x cubed. Therefore, the coefficient of x cubed is 3,969. This is the end of solution to problem 3. We go to problem 4. For problem 4, we have a and b. For a, we are to expand 1 plus y to the power of 4 in ascending powers of y. And b, by substituting y equal to x minus x squared, we find the expansion of 1 plus x minus x squared all to the power of 4. So we start with a, 1 plus y to the power of 4. The first coefficient is going to be 4 combination 0, then 1 raised to power 4, plus 4 combination 1, 1 raised to power 3, then y raised to power 1, plus 4 combination 2, 1 raised to power 2, then y raised to power 2, plus 4 combination 3, 1 raised to power 1, then y raised to power 3, and finally plus 4 combination 4, y raised to power 4. So simplifying the coefficients, this is going to give us 1 times 1 plus 4 times 1 times y, then plus 6. 4 combination 2 is 6, multiplied by 1, then y squared, plus 4, since 4 combination 3 gives 4, then times 1, then y raised to power 3, and finally 4 combination 4 is 1, then we have y raised to power 4. So in this case, we simplify finally to give us 1 plus 4y plus 6y squared plus 4y raised to power 3, then plus y raised to power 4. So we are done with A. We go to B. We are to substitute y equal to x minus x squared to find the expansion of this. That's 1 plus x minus x squared to the power of 4. So we go by putting y equal to x minus x squared. We are going to have it as 1 plus 4 into x minus x squared, then plus 6 into x minus x squared all squared, plus 4 into x minus x squared to the power of 3, then plus x minus x squared to the power of 4. Then we go ahead again to expand. So the first two here does not need serious expansion. This is 1 plus 4x minus 4x squared. This one needs serious expansion. So we can assist ourselves with Pascal's triangle. And since the power here is 2, this is where we have the coefficients. First, we expand this before we multiply by 6. So the coefficients are 1, 2, 1. The first term in the bracket is x. It takes the highest power. So we have x squared. It reduces by 1. We have x. So there's nothing here. Then the second term, which is x squared, we have the highest power from behind. So we have x squared to the power of 2. Then x squared to the power of 1. Then we now consider the sign. The power of x squared that's odd, we take minus. So here it is, it goes with minus, and here is even, it goes with plus. Then we now multiply by 6. 6 times 1x squared gives 6x squared. 6 times negative 2x times x squared raised to power 1 is going to give us x raised to power 3. 2 times negative 12x raised to power 3 will give us minus 12x raised to power 3. This is going to give us x raised to power 4 times 6, which gives 6x raised to power 4. So we are done with that. We go to the next term to be expanded, and that's this. So the power here is 3, so this is where we have power 3 and the corresponding coefficients. So we expand this first before the multiplication by 4. So the coefficients are 1, 3, 3, 1. The first term here is x carries power 3, so x raised to power 3, x raised to power 2, and x. The second term in the bracket, which is x squared, we carry the highest power from behind. So we have x squared 3, then x squared 2, x squared 1. We stop there. Applying the sign, the power of this that has minus, this is minus, this is plus, this is minus. So we then multiply by 4. Multiplying by 4, we have 4 times 1x3, which gives 4x3. 4 times 3 x squared will give us minus 12 x raised to power 4. This is x raised to power 4 times x to give us x raised to power 5. So 3x raised to power 5 times 4 gives plus 12x raised to power 5. And finally, we have minus 4x raised to power 6, since 2 times 3 gives 6. So we are done with that. Then we go for the last term here. The last term here is x minus x squared all to the power of 4. The power there is 4. And the main problem we are solving, they have the same coefficients, which is 1, 4, 6, 4, 1, 1, 4, 6, 4, 1, which means we are done with this triangle. So we go ahead to expand. The coefficients are 1, 4, 6, 4, 1. The first term here is x, so we take the highest power of 4 from the beginning, so x4, x3, x2, and x1. Then here is what? We have it as x squared, taking the highest power from behind, so x squared 4, x squared 3, x squared 2, and x squared 1. So applying the sign, positive or negative, odd power of x squared takes negative and the even power takes positive. So this is odd power, so this is minus, even power plus, odd power, this is minus, and even power, this is what? Plus. Then we don't have to multiply anything. This is going to give us plus x raised to power 4. This is going to give us x raised to power 5. X raised to power 5 times negative 4 will give us negative 4x raised to power 5. This is x raised to power 4 plus 2 gives 6, so 6x raised to power 6. This is 6 plus 1, 7, so we have minus 4x raised to power 7, and finally we have it as plus x raised to power 8. 2 times 4, 8. Then the next thing is collecting the like terms and simplify. So the first term here is a constant. The second term is just 4x, it is alone. The third term, the power 2, so we have this as having the same power. We simplify them. Minus 4 plus 6 gives 2, so we have plus 2x squared. The next power is power 3, so we have it as minus 12x raised to power 3 plus 4x raised to power 3, and that will give us minus 8x raised to power 3. Then we go for power 4. 6 minus 12 gives negative 6, plus 1 gives negative 5, so we have minus 5x raised to power 4. So the next one is x raised to power 5. This is 12 minus 4, giving us 8x raised to power 5. So x raised to power 6 is the next target. So we have minus 4 plus 6, which gives 2x raised to power 6. So the next term is the one with power 7, and it is only one term we have. So we have it as minus 4x raised to power 7 then plus x raised to power 8. We are done expanding the two problems A and B represented in problem 4. This is the highest we can take in this tutorial. I hope you enjoyed it. Thank you for watching. Remember to subscribe to our YouTube channel. Don't forget to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binomial expansion, including Pascal's triangle. Until we come your way again, goodbye.